Hi, this is James Governor, co-founder of RedMonk. We're here for another RedMonk conversation. This is a good one. I'm excited today that we've got Boris Bialek from MongoDB here. He's one of the field CTOs at the company. Are you the only field CTO, or are you?
No. One is not enough these days anymore.
One is never. So let's have some more field CTO.
My area is industry solutions. So I'm working mostly with large scalable industry things from FSI, manufacturing, retail, and all in between.
Okay, so field CTO, you're getting out there and actually working with the customers. Is that right?
Correct. Yeah, I'm a really dangerous person. That means I work with clients. I actually implement what I talk about, and I see normally the outcomes as well, good and bad sometimes.
Okay. Well, let's talk all about the bad. No, we'll talk about a bit about both. But so here's the thing. I've known you for quite a while. I knew you in the good old days of working at IBM with DB2 technology. Lots and lots of claims about how scalable that database was at the time. You've ended up at MongoDB, and I think here's the thing. You're someone that has been working at the cutting edge of database scale for many years now, I guess decades of experience. Here's the thing, MongoDB, I mean, it's sort of a reputation. We even had that joke, it's web scale. Sort of the joke that it actually didn't scale. There's been a lot of people, they've got this consideration, MongoDB, yeah, no, it's not as good as these other databases. I think the reason I wanted to talk to you today is you had some examples. We've been chatting, and I think maybe we have, maybe you're not just like a tiny little putt VW, and in fact, a bit of a high performance engine now. So let's talk about that, about scale, real scale. And I think you've got some good examples that we can talk about, where MongoDB, frankly, is showing some impressive throughput.
Absolutely. And the interesting part is what the biggest part is where I'm always stumbling about is when people ask me, and you're a no SQL, so you are not ACID compliant, are you? That's normally the starting point of an interesting discussion, because first thing is MongoDB is ACID compliant. Each document get logged. We have beautiful log files, what people really appreciate in the database space, and all the things surrounding it. But as soon as you start logging, you start around discussing the old problems. How can you log enough transactions? How is transaction behavior happening? And one of the most amazing one was to work with Temenos, what we've done last year. It's by now a year ago, 2023. Can you imagine that? And
what's Temenos?
Temenos is a core banking platform. And as somebody who's working as long as me in databases, never trust a benchmark, which you've done yourself, is a standard term. Mm-hmm. And specifically vendor benchmarks are very famous. When a third party is using your software,
are you saying that we couldn't trust TPCC and its pump? What do we?
Oh, sure. Remember the 0.1 cent per transaction, depending on the single hard drive for a database. No, but going back to the part, there's some truth to it. You want to see some real workloads, and there are not that many comparable workloads out there where people put it through the motions. And when Tony Coleman, the CTO of Temenos, asked us, "Are you guys ready?" We took basically the work from the last years and put it through a real high-powered test. So the long story short, 150,000 banking transactions per second. Now people will say, "Oh man, we had billions of transactions an hour."
I thought you weren't allowed to bank on MongoDB, aren't you?
That's exactly the funny part, right? And when you look in banking, each transaction suddenly becomes 20 database transactions involving 6 or 8 different, what we call collections. In the old lingo, you could have called this tables. It's not fully comparable. Okay. But then we're talking actually multi-document transactions. Hello, like multi-table joins. Some people may remember the old days. And then when you take a look to this benchmark load, and we are doubling performance versus earlier systems in the relational space, and things like code path lengths coming into play, transparency of data, real JSON data, which are really—
And these are financial transactions. This isn't like business transactions in the sense of customer service or some other—
Correct. This is like opening an account, which consists of creating the account owner, creating the account, creating the balance system. So there's a lot of things involved in that one, or processing a mortgage or things like that. So these are quite complex things which happen in the background. And that is the part where it became exciting for me. When we've done this test, it was for me, if we can do this one. And the assumption was, by the way, a really funny number now again, 200 million clients, 100 million clients with 200 million accounts, something like that. So that's a pretty decent size of the bank. And after that one, we can do any system in the transactional space. And this is the scale what we talked today about. The fun part was we used only a single MongoDB partition. We're not even getting into shardings. We had one single MongoDB. We could have scaled this out to 100 partitions. We have clients out there with 1,000 shards in the system.
Okay, so let's talk about some of those really big scale examples that you've got, because I think some of the numbers are pretty impressive, not necessarily what people expect.
Yeah, you see by our clients in the infamous petabyte size. You and I, we were remembering the days when people said, I'm in the terabyte club. And people are really, really excited. But today, a petabyte is a little bit different discussion from the size in between. And we see that one that people get really, really into large-scale data. The interesting part is these are transactional systems. These are not in the data warehouse space. People built, even in the old days, really funky large data warehouses. Mm-hmm. We talk about transactional system running millions of transactions, interpreting data on the fly in real time and making decisions out of that one on single data sets. So this is the thing where people get a little bit lost, and I always call it the hoodies and the codes. You have the lab codes in the data science department who come out with great spreadsheets at the end saying 42. And what we are doing is really the transaction out there. You have a transaction, something hot running. Somebody's ordering shoes. And the system tells them, dude, you really want to have the size 9? What about 9.5? Because accidentally we know out of 100,000 orders that you should be a 9.5 and not a 9 based out of your other purchase behaviors. That is value add. This sounds now a little bit more creepy than it is. Saves you a return, happier client, happier shoe.
Okay. Okay.
And now we're talking millions of those in parallel in large systems. People don't even realize how many retailers rely on us. And if you take a look, there's a very large part of us, Commerce Tools. They're providing the infrastructure with some of the largest luxury brands in the world. And sites like Verizon.com is one of their reference clients if you check out their website. And now imagine people ordering the new iPhone. Mm-hmm.
Yep,
we're talking suddenly spike at unbelievable loads happening. Yeah. Everybody wants the latest order. We handle all of that one with them as an ISV, but the underlying database is MongoDB for these kind of solutions, which is quite amazing to see. And for the way how we work today, transactions per second is translating into baskets per second, mortgages per second, requests per second. So all very industry driven. As you know, I'm the industry dude, so.
Okay. Yeah. So I think one of the other things that where you've been doing some work is in and around automotive, which is a slightly different use case. Obviously, that's not so transactional. But again, when you're looking at telemetry, data collection, there are some pretty interesting data points in that space as well, right?
Oh, absolutely. And the funny part is it becomes very transactional today. Historically, when people collected data from cars, it was you drive the car to the garage and then comes this, what's your mileage today? And that was a data point they had. And then they maybe look it up and saying, oh, that model needs, we have actually fallback. We update your software. That was already the luxury version. Today, we do this in real time. MongoDB, we have demos running. We just demoed a little bit plug here at CES together with Covesa. That's the vehicle vendors together in software lines. And we demoed there how we can run an integration of MongoDB inside of a car. Think about managing electrical batteries in real time. Suddenly the transaction density become really, really high. Think about braking systems. So how many transactions you need to check for optimized braking system for an automatic braking behavior?
There's a lot of people out there that are not going to be, they're going to be feeling a little bit weird about MongoDB controlling their braking systems.
It's not MongoDB controlling it, right? It's right. Just think about tracking it, and it wants you to tell you, by the way, your brake pad is really gone, and I will be very slowly down on the highway. You're not driving 220 miles on the I-10 in Los Angeles anymore. No, I slowly put you to the exit. And oh, by the way, the next repair shop is already informed that your brake pad ripped and I get a repair. These are life-changing situations, right?
What are the companies, what are the automotive companies that are linked to Covesa?
Oh, the group in Covesa is really everybody of the world by now. So If you look up their website, it ranges really from BMW to the Japanese vendors to Ford. Everybody's in there. So not everybody's using MongoDB, to be very clear. We're just one option, obviously. But we have a lot of partners out there who are doing cool stuff. And when you check out some of the presentations, there is the right things happening. And the data amounts, we can generate terabytes of data in a car by the hour. So suddenly say, wow, but even if you pre-condense data, we talk about the breaking system, we don't really care what happened in the last hour. What you care about is what is long-term view. So that's time series data, classical time series data manufacturing or in vehicles. And those we can deal with data in real time on large volume, then connect to the cloud and decide maybe, oh, you want to open the car. Yes, you can do that too with your cell phone. And that is actually a lot of interesting communication. Is your cell phone connected to the cloud, or are you having only a Bluetooth connection right to the car, which then needs to authenticate over different security mechanisms? You see where I'm going. There's a lot of data behind this. And all these data make the stuff really, really exciting.
Okay, so talking about exciting and excited Boris, when we spoke a couple of months back in London at a MongoDB event. And yeah, I mean, basically, you were just coming up with sort of these high scale numbers after high scale numbers. Give me the most excited you've been in terms of throughput, in terms of some of the scalability characteristics some of the stuff that you found most exciting in terms of the work you've done as a field CTO in the past, I don't know, couple of years.
And the most exciting ones are the smallest ones as well, partially, because when we think about this, back to your car example, we're not talking that the vendor, oh, by the way, we put a real cool data center in your trunk. That's really not something which is a selling argument. We're talking very, very small embedded SoC, systems on a chip, which run MongoDB on one side and run these transaction workloads, what we talk about in the thousands. And then let's move to the complete other side on the back end, where we consolidate millions of car informations into large workloads on the cloud workloads on global scale, global distributed database, let's say 10, 20 million cars. So that is a differentiation, what we see. And then the most exciting workloads are really the large transactional banking systems, what we're running on these days. Sure. It's amazing to see what people can do with MongoDB, specifically on the trading settlement. And we are not talking necessarily high frequency trading. People get then really, really confused about that one. Those systems are in memory and normally not really persisted, but sooner or later, these trades become a real trade and need to be persisted on a system. And that's where MongoDB shines by now. Think about something very simple. Each document can be a financial instrument. You don't need hundreds, thousands of different tables. You can write an ETF purchase, which you just did yesterday for your pension fund. And today you want to buy MongoDB stock because you think we're a really, really great suggestion. So when you take a look at that picture, or maybe you want to buy somebody else, so Microsoft, buy Microsoft, they're just $1 trillion company. So if you look at that picture, all these things historically were different tables, very large scale, very complex. We can write this into a single table, into a single collection, and write them down, hundreds, millions of them, into one system, distributed globally. So because, James, you have a great business, and because I can't use the real bank we're using this one for, but imagine you have Tokyo, London, and New York to cover. Now we can build a distributed system which runs one database over all three locations, that everybody has all their data, but the trades in New York happen first, get committed into New York, fully redundant, fully recoverable with multiple nodes, but then they have a copy in London and copy in Tokyo, which maybe takes, now there's a runtime delay. We can't optimize still speed of flight through optics, but that one we have. And then this is way better than before. Oh yeah, end of the day, we copy the data. Yeah, end of the day versus sub-second. Think about counterparty credit risk. Think about the Lehman moment, right? Make sure you don't pay out the money 1 second after they're bankrupt. Things like that can become very exciting. And those are the systems in large scale which we are running, where we talk the hundreds of millions of transactions running by the hour.
Okay, so hundreds of millions of transactions per hour, financial transactions. And that's the sort of throughput that you're increasingly seeing in the customers that you're working with.
Correct. And when you think about, wait, Boris, you talk system on a chip in a car. Now you talk financial transaction, globally distributed clusters. That is the piece which makes it so exciting. And this ranges from things like post-sales post-trade settlement, to things like risk computation, how much do somebody owe me, to mortgage onboarding and figuring out, hey, James wants to get a mortgage. Oh, we have all the data about James because he's a long-standing client of us. Mm-hmm. So instead of making him print out 500 pages of documents, why don't we use the information we have and sell, James, you're a highly valued client, you get 2% off your next mortgage, which would be amazing. Admit it.
My mortgage is locked in. That was the one financial thing that I've done quite sensibly recently. Took a 10-year. I'm very happy with my mortgage at the moment when interest rates before they spiked. So that was good news. But at some point, I will need to probably do this again. Okay. So I think that was the key thing that I really wanted to talk to, this question of scale. It's just to finish up, Boris. There's different dimensions of scale, obviously. This is throughput, sort of reliability, availability. What are the key dimensions in scale as you see it? And how is as MongoDB and the Mongo storage engine, optimized for these different characteristics today? Like, where do you think those sweet spots are? What are the optimizations you can do? As you said, I mean, we both remember that sort of you always had the decision support as opposed to the transaction processing, different things. Like what from an engineering perspective does scale mean in 2024? Where are we going from here? And how can you enable optimizations accordingly?
And this is really the question, and it's a good one, because availability today is a table stake. When we started, there were failover systems, and people talked about what failover time we had. And then you saw some companies were down over weekends because certain database vendors, luckily not mine at that time, could not recover in time, or the backups were damaged and stuff like that. We are talking right now about a zero downtime, zero tolerance actually from the clients. When you think about, you cannot take an online store offline because you run a maintenance window on your backend. That's a non-given. So MongoDB is by default a cluster system. So we always have normally in the larger system, not in development, you can have a local system on your laptop, no problem. But when you talk about you want to run 100 million financial transaction now, you may want to have redundancy built in from the beginning. So you start with 3 nodes. And my joke normally is one is active, one is working, and the second one is on vacation. So, and that's pretty much the same picture here. But the key part is all nodes are active. You have what we call a principal, but the other 2 nodes are delivering read performance. And now on top of that one, we can scale this one out. We can say, well, honestly, we had this example about the multi-distributed environment geographically. We have three nodes in New York, 2 in Tokyo maybe, and 2 in London, because we don't even want to risk that London gets completely shut down. And London is maybe distributed over 2 data centers, so that each area, so suddenly we talk about 7 nodes inside of one of these partitions. And now we multiply this by 3. And because we have London Prime, Tokyo Prime, and New York Prime, so you have suddenly this orchestration, these kind of systems, this is managed inside of MongoDB. You as a person don't need to understand it. You don't need to plan with it. The developer doesn't need to deal with it anymore. You and I, we remember times when people needed to fine tune on which partition with all the stuff doesn't exist. Mongo takes care, understands what is the nearest solution. You take it New York, it is, and the application goes first to New York for the New York transactions. Done. This kind of simplicity are table stakes today. But the next part is then obviously now I want to scale out. I want to scale in size. The example with Temenos, where we went to a bigger system. Or you want to say, you know what? I don't want to have all these big baskets. There are economically reasons as well. Smaller systems are cheaper in comparison. So give me 20 shards, distribute my data over 20 multiplied by the 3 or 5 nodes. And now comes the next level. We want to make real-time decision-making. I want to have real-time search on all my data. I don't want to be dependent on an export to a search Lucene engine. All the stuff is integrated in MongoDB. We call these workload isolated nodes. You can run search in real-time on this data. Now we're getting back to my comparable part about the hoodies, right? Developers want to have real-time decision-making. If you add a new product, you don't want to wait. Oh yeah, the next upgrade on the search comes in 24 hours. You lose 24 hours of sales. Worst case, the thing is sold out before we have it in the search index. No, you need this real-time integrated. And the next part is obviously GenAI. How can we have a podcast without mentioning GenAI, James? So
we've done pretty well. We've got through quite a few minutes before we got to that, before the marketing hack came on. But
yeah, it's not marketing, but it's the same thing again. The lab suits with the data science versus the hoodies. And the hoodie side wants to have GenAI real time. I want to suggest the right shoe size for you. I want to make sure that the mortgage is correctly processed for you and that you don't need to deal with all the 500 pages. All of these kind of stuff are real-time applications. Now we have things like vector search in real time integrated in MongoDB. So you can actually run your data. Let's think about the financial transaction. You build a vector over this one and analyze in real time the behavior of this and maybe the impact on the counterparty credit risk, the Lehman discussion again. So when you do these kind of things, this is what makes Mongo different, that we have all these things integrated. And this is what makes me as somebody who's really big in transactional processing so happy to talk about it, because you can do things without copy. As soon as you have ETL, you and I, we both know you lose minutes or hours. Real time. And not only, oh yeah, I have there maybe Kafka and you can do that. This is nothing wrong with that design for many solutions. But when you talk real time, the transaction comes in and I need to make a decision based on this transaction now. And that is what MongoDB can give you. And with the scalability and the reasons come in why people do that. And that includes GenAI, vector search, or the integration to your LLM on the shoe size.
Okay, there we go. So I think that's enough. That's enough. I got it. Here's the thing, folks. Basically, this was the key point. Why I wanted to record this with Boris is the old-time transaction guy. He's been about transactions his whole career. I think for a lot of you, you don't necessarily think of MongoDB and transactions. And I just thought, rather than all of the other things that we could talk about, developer experience, GenAI, any of that stuff, let's just talk about the basics of scale and transactions, where MongoDB is. As you can see, Boris is pretty excited about this stuff. So that's all to the good. Boris, thanks for joining us. That's another RedMonk conversation. And if you're interested in this content, if you'd like to see more, please subscribe, share this stuff. You know, we are trying to foster a conversation. We're always interested in engagement with the community. So thanks for joining us. And thanks, Boris. And I'll see you all soon.
Thank you, James. Bye-bye.